For this segment, I'd like to solve the equation log base 2 of x plus log base 2 of x plus 6 is equal to 4. Now, when we're solving logarithmic equations, it's important to make sure that we write it in a form that we can go with our logarithmic form to exponential form at the end. We also need to make sure that we check all solutions to make sure that our answers do work in the original equation. Now, in this equation, I have two different terms that involve the logarithmic of a variable expression, and then I also have a constant term on the other side of the equation. In order to get to the point where I can write it out of logarithmic form to exponential form, I need to condense the expressions on the left-hand side that are the logarithmic expressions if I can. Here, I can use the properties of logarithms that it says if you're adding the logarithm of two different expressions that have the same base, that I can rewrite that as the logarithm of that base of the product of the two expressions. So x times x plus 6. And that is equal to 4. Now I've condensed this expression into the log of a quantity is equal to a number, and I can write it out of logarithmic form to exponential form. Remember, logarithms are exponents. The logarithm base 2 of the quantity x times the quantity x plus 6 is equal to 4 means the exponent you put on 2 to create this expression is 4. So when we rewrite it out of logarithmic form, we have our base 2 to the exponent power 4 is equal to the expression x times the quantity x plus 6. Now, I do have other videos talking about how to rewrite out of logarithmic form to exponential form, and you may want to review that if this step isn't quite comfortable enough right now. Well, now that we have written it out of logarithmic form to exponential form, we can go ahead and solve it. 2 to the 4th is 2 times 2 is 4, times 2 is 8, times 2 is 16. So I have 16 is equal to x times the quantity x plus 6. We'll go ahead and distribute the x on the right-hand side. That's 16 is equal to x squared plus 6x. And now we see that this we can solve as a quadratic equation. Let's go ahead and try to see if we can solve it by factoring. Now, to solve it by factoring, we need to make sure that we get 0 on one side. So we'll subtract 16 from both sides and get 0 is equal to x squared plus 6x minus 16. Now we see that x squared plus 6x minus 16 factors as x plus 8 times x minus 2. Setting each of these factors equal to 0, x plus 8 equals 0, or x minus 2 is equal to 0. And then solving for x, we see that x equals negative 8 or x equals 2. Now, these are possible solutions of our equation, but we can only report the solution that actually makes the original equation true. And remember, logarithms are exponents that you put on the base to create the quantity, and over the reals, we can only look at logarithms of expressions that are greater than 0. So if I try to put in negative 8 for my x's, this first one would say log base 2 of negative 8. Well, that's undefined. So I can't replace my x's with negative 8. How about 2? Well, log base 2 of 2, that's the value 1, plus log base 2 of 2 plus 6. Well, 2 plus 6 is 8, and the exponent you put on 2 to create x is 3, and then 1 plus 3 would give me 4. So that does work as a solution. So our solution to this equation is x equals 2.